In this short video, I'm going to give you an example on how to build a field development strategy for a synthetic asset. So here's an asset. The geology looks quite simple. It is a single dome, but what we can see on the left map is there are several possible faults which we can't first say are transparent or sealing. Here's the current situation with the field. So here, as you can see in the review, our current recovery factor is only 0.24. The target recovery factor is 0.5. And well, one can see that we would probably be even able to reach this recovery factor, but it would take us a long time. So what we can do now is to increase the speed of recovery and speedify the development. So from what we can see in the right table, the voidage replacement, the cumulative, is 110%. The current is 120, but still the current formation pressure is only 75, and the initial was 125. So it means that we are injecting more liquid than producing, but the pressure is still dropping. So probably, as you can see from this table directly, we do have a problem with the water flood. Let's take a look at the pattern. Here you can see the producing and injecting wells. So from the cumulative and the current production map, you can see that in the southern part we do have many wells which produce mostly oil, but the production rate is very low. And here in the northern part we see several wells where the production is quite high, both current and the cumulative, but we do already see a high water cut in those wells. Now let's take a look at the pressure distribution. So we've chosen several wells and ran a pressure build-up. So here you can see the values of reservoir pressure around several wells across the field. And from what we can see here is, first, in the northern part of the reservoir, the pressure is higher than in the southern part. So here it's like 80 plus, while in the southern part is like 70 minus. Another thing that we directly see here is a very low reservoir pressure in several injectors, such as injector number 10 and injector number 22. So low reservoir pressure in an injector well could only mean one thing. It is a non-productive injection, thief injection. And that is something that we might test with the case hole logging. As long as we have different pressures in the southern and the northern parts, and also we have different situation with the reserves, we do understand that the water flood strategy should be also different. So if the southern part is severely depleted and also has most of the reserves, it means that most of the injection, which is limited by the way, should actually go into the southern part to increase the pressure in the region which is still rich with oil. As to the drilling strategy, so if we build the correct geology, if we correct the mistakes of the previous petrophysical team concerning oil-water contact, concerning the reservoir continuity, we would see that the current reserves map looks like this on the left. And then we would be able to place several wells here, such as first we would place S2 here in the very rich spot, then S1 as an injector well supporting these offtakes, then S3, S4, both injectors, S6 here and S5 here, and actually this configuration of the wells would provide you a very good result, probably the best possible result of development. Anyway, apart from drilling, we also need to plan the workovers. And we also need to prioritize. Also, we need to prioritize between drilling and workovers, because you would have a very limited amount of money and you need to understand what to do first. So you need to carefully prioritize. So on a very simple technological level, with an example of workover here in well number 10, we can fix the channeling, which we do see in well number 10. Then we can increase the injectivity with a frac job on well number 10, which would allow us to inject several hundred cubic meters more into this well and into the right layer. And that would give us the direct response on the offset producers, and this additional injection would be converted immediately into oil production within a year, and that would give us a very high economical result. So we would have like 200 plus cubic meters of oil in production. And here's a question: would we be able to drill a producing well with 200 cubic meters production? And the next question: even if we could, would it be more expensive than to run a workover here in well number 10? And the answer is, of course, yes. So in terms of prioritization, if you have a very nice and technologically successful workover, which is way cheaper than drilling, then you go with the workover first, of course. Then we need to analyze what to do with an injection, because actually in some projects, in some assets, we could still use the reservoir pressure and we could deplete it furthermore, and still that would be the best economical strategy. But we can actually calculate, using proxy models, calculate the decline rate of oil. And in this particular case, with an example of this asset, we can see that the decline rate would be very slow if we inject. And we can technologically successfully support the pressure in our producers, allowing us to produce more oil year by year. So in this particular case, we need to go with the waterflood. Another thing is planning surveillance and planning case hole logging, which could be sometimes quite expensive, but sometimes we can save some money, at least some money. It's always a bad idea to save on surveillance, but sometimes you can see the results of a previous case hole logging from the previous team. And if you already see the channel in the case hole log, which is been given to you as for free, then probably there's no need to run an additional case hole logging. So here, as an example, on the top picture, you can see the temperature profile in some injecting well. And here you can see that several layers, even after you shut the well, stay cool. So what happens here on this picture, you see the temperature profile while the well is injecting, and then you see the temperature gradient profiles while the well is shut. And you can see that the well is warming up, but for the layers which have been taking water. And on this picture we clearly see that reservoir A1 has been taking water, and that is why it's so cool. And it means that even though it's not perforated, it's taking water through the channel. And that means that we have a thief injection which we need to fix. And on the next picture here, you can see that I've just conducted the case hole logging, the cheap one. I can see how much water and oil is coming through the perforations. I don't see what's going on behind the casing, but I can see that most of the water I'm getting from the lower perforation. And if I see the indication that I might have a thief injection in this well, I may already know where it is coming from, because in this particular case it has to go from underneath. So now let's sum up. Let's build the strategy. We need to repressurize. and we need to redirect the injection to the southern part because it is much more promising in terms of reserves. We need to drill several new wells in a southern area, and we need to support the production from the new wells with the new injection. So it means that if we drill, we need to drill half producers, half injectors. If it comes to prioritizing the workovers, we need to perform the workovers in injection wells, because again the field is deeply depleted and we need to quickly repressurize. So first water shutoffs, then water shutoffs on producers, and then, only then, reperforations and increasing productivity index by, well, for example, hydraulic fracturing in the producers and injectors. And then injection and production targets should be increased year by year, considering the vertical pressure gradient, so not to create the new channels which would cause new thief production and new thief injection. So on a very high level, this is how you build a strategic view on how to develop a reservoir in the next several years. Thank you very much.